I don't really. I think this is pretty casual too. I don't really become formal. Yeah.
Did you guys watch the last video?
So you have it, right?
Yeah.
No, it's like how we need
So let's get started. The first problem we have 1.2525 repeating. On the exam, I had put 1.225, something like that, by accident, but then I changed it Saturday night or something. Sarah mentioned that to me, and then, so it should be correct right now. So if you didn't look it before, then nothing, then don't worry about it. So we know that the part that's repeating is 0.25, so we can just do 1 plus 0.2525 dot dot dot, because the repeating part is 0.25. Yeah. So this is equal to 1 plus 0.25 plus 0.0025 plus dot dot dot. Every time the 25 is being moved by factor of 100. So our first term, looking at this section as a geometric series, our A is equal to 0.25. Our R value, which is the factor that is changing by, is 1 over 100. So that's 0.01. Because every time we're going from 25 to like the next unit, we're multiplying by 0.01 to move it 2 decimal places to the right.
You also write that as 1 over 100.
Yeah. So then the formula, or this is equal to 1 plus A over 1 minus R. That's equal to 1 plus A, which is 0.25, divided by 1 minus 0.01, which is 1 plus 25 over 99, which is equal to 124 over 99. Any questions on that? There will for sure be a problem like this. Yes? Yeah, so if we imagine this is our first term, we have to multiply by 0.01 to get this term. We added 2 more 0 places, or moved the decimal places 2 digits to the left. So we divided by 100 to get this. We divided by 100 to get the next term. So our R is 1 over 100, or multiplying by 0.01. Any more questions on this problem? And then you can try different versions of it to get more practice. For 6A, it says to prove the sequence converges or diverges. And since it says a sequence, how can we find whether it converges or diverges? Where's the other sign-in sheet? Okay. Make sure everyone signs. It's not technically the nth term test, it's the limit as n approaches infinity, since it's a sequence. So the sequence is k cubed plus -1 to the k power k squared divided by 2 plus k cubed. What we do is we do the limit as n approaches infinity of a sub n equal to, we divide this, so k cubed is the highest term, so it's the highest term with the highest degree. We divide everything by k cubed to get 1 plus -1 to the n power divided by n divided by 2 divided by n cubed plus 1. Do you guys all understand that? No? We essentially did 1 divided by k cubed on top and 1 divided by k cubed. So then as n approaches infinity, what are we left with? 1. Because the -1 to the n power oscillates, but that actually shouldn't even matter since it's divided by n, which means this term goes to 0. And so does this term. We're left with 1 over 1. Yeah, so we can say, therefore, the sequence converges to 1. So that would be the L value, yeah.
So for the interim test and the interval test, we only use that for series?
Yeah.
Why do we do the interim test? You goes to numbers like, oh, it diverted. When we do it for sequence, it's like, oh, it converted.
It's just in the basic idea, like a sequence is not being added together. It may be something from that, yeah. So any other questions on this? So if it's a sequence and you're told to find whether it converges or diverges, just do the limit as n approaches infinity. The next one, we have to prove that the integral test applies. So from k equal to 1 to infinity of 1 over quantity k plus 1 squared. That's just knowing the 3 conditions and then showing them. Be careful because he may have a question where the integral test does not apply. So then in part C, it says use the integral test to prove. You have to put it does not apply or something like that. If for some instance it doesn't apply, don't assume it's going to apply. Because if it doesn't meet one of the conditions, like the derivative is not less than 0. Understand that? Yeah. So he may trick you like that. So the first is that f of x is increasing. So since this is a series, it's not a function, but for the integral test to apply, it needs to be a function. So we have to make it like f of x. That's equal to 1 over x plus 1 squared. And we know that has to be greater than 0, with our starting value being 1. Any questions on that?
So for these, do we have to show the first 3 terms, like to show that it's a continuous function?
No. You can just write that. Oh, they do show this one. So a n is equal to 1 over n plus 1 squared. So f of x is equal to 1 over x plus 1. You need to show this to show that this is a series and f of x is a function. I said that, but I didn't write it. Second part is you have to show that it's decreasing, or that the function is decreasing, but if its derivative is negative, you know it's decreasing. So there's 2 ways to do this. You can show that a sub n plus 1 is equal to 1 over n plus 1, sorry, n plus 2 quantity squared. And we know that has to be less than 1 over n plus 1 squared, which is equal to a n. Therefore, it's decreasing. Or the other way to do it is to show the derivative. So f prime of x is equal to negative 2 divided by x plus 1 quantity cubed. And since that's less than 0 for x greater than or equal to 1, therefore it's decreasing. So both ways are valid. Any questions on that? Because the n plus 1 term, since it's a bigger denominator, it has to be lower than the a sub n, so that we know it's decreasing. And since the derivative is negative, it's decreasing. And the last part is we need to show that it's continuous. So we can say f prime of x is equal to negative 2 divided by x plus 1 cubed is defined for x greater than or equal to 1, because we don't get an undefined term or anything, so there is no conflict. Therefore, f of x continues. Is that what you were asking? Or you were asking about saying this term out? Yeah, you can just show that. Any questions on those three?
So if it didn't work out, like, oh, it fails because so and so is not increased.
Yeah. Say we started at a -1. So it wouldn't be continuous if we started at a -1.
Yeah.
So no, our series starts at k equals 1. That's where I got the 1. You guys all hear that? Okay. So then the integral test is to prove that it converges. We do the integral from 1 to infinity of f of x d of x. Since it's an improper, since we're going to infinity, we do always need to show that the limit as b approaches infinity from 1 to b of the function dx over x plus 1 quantity squared. This is equal to the limit as b approaches infinity of x plus 1 to the -1 divided by a -1 from 1 to b. And this is just solving the integral. So the limit as b approaches infinity of -1 divided by b plus 1 plus 1 divided by 1 plus 1. So since b is in the denominator and we're approaching infinity, the first part goes to 0. We are left with 0 plus 1/2. Therefore, the integral converges. Therefore, the series converges. And what does the 1/2 tell us? Nothing. It just tells us that it converges. It doesn't mean that it converges to 1/2. So any questions on this part? So using the integral test shouldn't be hard. It's just knowing what to do. So you have your 3 conditions, and then you do the integral of the function. And you should always show this part up here to show that you have a series, but then you're doing the integral test by making it a function. A series is not the same thing as a function. Yeah.
Do we also have to show the a sub n, or we just show that fx or whatever?
Did they show in class?
Yeah. Sometimes over like we have put in it's equal to that, and they'll say like therefore f of x is equal to this.
I would show both of them just in case if you remember to do it, but definitely show the f of x part and say f of x, or like write the word say f of x is equal to, okay, to make sure you clearly know that it's a series and then you're making it a function. Can I pull it down? No. So are you guys all good with the integral test? It shouldn't. I mean, they always make things tough, but.
Wait, you mean it is only a course?
What? I didn't hear you.
Oh, did you need it in the weed out class?
Yeah. My recommendation is if your GPA is hurting because it's a VDOT class, join some activities to put it on your resume for co-op. Okay? Because that it's really important that you have some activities. Because most people just have their courses and then their GPA and that's it on their resume. Okay? But now you have plenty of time. So, all right, moving on. Because, like, I have a lot of research experience. That's what I put on my resume. But you guys should do research or something too, because then that just bumps you up a lot, like tremendously. Let me say that. Because there's a lot of students fighting for co-ops. Okay? All right. So the first part is use, all right, guys, use partial fractions to find S sub n equal to the summation of k equal to 1 to the power n of 2 over 4 k squared minus 1. And they tell you to factor first, okay? So if we make this an a sub n equal to 0 n plus 2 divided by, what can we do to the denominator? 2n minus 1, 2n plus 1. So if you had said, well, keep it in terms of n because we want s sub n. Okay. If you did a sub k, you would just need to show it with k. But they wanted s sub n in the answer, so then you would need to show it with n's in the answer. So we can, since we have two fractions here, we can break it up into two parts. A over 2n minus 1 plus b over 2n plus 1. You guys all understand how to do those? If this was squared, you need something with a squared with that part as well in there. If we had 2n squared here, this would be an plus b, something like that. You guys all understand that? That's in your dyno slide. So what method do you guys want to use? Because, yeah, the best method would be the method 1, if we just for this. What? I like the heavy side, but let's just go with method 1. Because it's not complicated here to multiply them out. Yeah. Normally I prefer the heavy side already.
Is that what you guys only do with that differentials?
With hybrid method. So on the exam, they may tell you a problem, use the hybrid method to solve. Okay? And if you use the first method, you'll get 0 points. Remember that. Always follow the instructions. Yeah. So if they tell you to use method 1, don't do heavy side in the hybrid method. Okay? So we have a times 2n plus 1 plus b times 2n minus 1 divided by the fraction denominator, 2n minus 1, 2n plus 1. On the top, to get n's on one term and stuff, we can do 2 times a plus b times n, or let me slowly show. So on the top, if you multiply them out, we have 2a times n plus a plus 2nb minus b. If you multiply the top out, and if we are to factor them or group them, we have 2 times a plus b times n minus or plus a minus b. So then we can rewrite that as equating the common coefficient stuff. The ones with the n are 2 times a plus b equal to 0. The ones with the n to the 0 power, essentially, is a minus b equal to 2. So then, if we subtract them, we have a is equal to 1, b is equal to -1. Any questions on that? So then our a sub n is equal to 1 divided by 2n minus 1 minus 1 over 2n plus 1. And just by looking at those two fractions, you should know what kind of series this is. Telescope. Because essentially it's going to add some things and subtract it, like, and go back and forth. And that's, yeah. And if you don't see that, you can show it by writing out the first two terms.
So does that mean we wouldn't have to do the actual vacuum terms?
What?
We could maybe just show that 2 over 4k squared minus 1 is telescoping and then give them some based off that.
You need to show like the first 4 or something.
We need to write it as S sub n again, so they say fine S sub n.
Yeah. So S sub n is equal to the summation of k equal to 1 of n of a sub k equal to, so if we were to plug in a 1 in there, we would have 1 minus 1/3 plus, if we were to plug in a 2 in there, we'd have 1 over 3rd minus 1/5. Now, they show more than that, but that should be good enough to just put a dot, 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 plus one over 2n minus 3 minus 1 over 2n minus 1 plus 1 over 2n minus 1 minus 1 over 2n plus 1. This is when we plug in an n minus 1 in there. So I think just putting these and then the very last two should be good enough. Okay? Yeah. So you don't need to, yeah. So just putting these two last two and the first 4 or something should be good enough. But you do need to like show that the 1/3 cross out, that the 1/5 will cross out, and all of these cross out. So you have just at the very end, you have S sub n equal to 1 minus 1 over 2n plus 1. Any questions on that? So this was just like heavily algebra based.
How did you say you got the 3 in that? The 2 minus 3?
If we had a n minus 1 in there. Because that would be the term before n. It'd be 1 less. Do you guys all copy this down? What? No. We're not going to talk about that. Okay, part B of it says, all right, guys, use A to find what it goes to. So S is equal to the summation of 2 of infinity of k equal to 1, 2 over 4k squared minus 1. And that's equal to, we can say the limit as n approaches infinity of S sub n equal to the limit as n approaches infinity of 1 minus 1 over 2 n plus 1, and that's equal to a 1. Any questions on that?
Just like all the problems of like S equals summation, limit n versus S.
Yeah. So if you have S sub n, this part should be really easy. So the next problem is re-indexing k equals to 4 going to infinity of k squared divided by k minus 1, and we want it to start at k equal to a negative 1. Okay? So what you have to think of is, what's the difference between 4 and to negative 1? It's 5, right? And we're lowering it, so we have to add 5 here. So this is equal to the summation going to infinity of k plus 5 equal to a 4. And since we're substituting k with k plus 5, we need to substitute everywhere in the middle. So we have k plus 5 quantity squared divided by k plus 5 minus 1. So then we simplify that, going to infinity, k equal to negative 1 of k plus 5 quantity squared divided by k plus 4. Any questions on re-indexing? You find the difference between your k starting value and what you want it to start with. So in this case, it was 5. Since we are lowering it, we add 5. So it's k plus 5 wherever there is a k. If we were raising it, we would do subtraction.
Which is more efficient, re-indexing or doing it in terms of a different k value?
Re-indexing. Because you do problems where you need to re-index it, and then you have a geometric series that works or something. So any more questions on this? No? Okay. Are you guys ready to move on?
Yeah.
Okay. For 9, we have the summation of k equal to 1 going to infinity of negative 1 to k divided by 2 to the k plus 1 power plus 2 to the k minus 1 power divided by 3k. And we have to find or solve it, what it goes to. So we can show that just looking at the first few terms, we have, by plugging in a 1 on the left one, we have negative 1 over 2 squared plus a negative 1 squared divided by 2 cubed plus a negative 1 cubed divided by a 2 to the 4th. And the first series goes on. The second series is 2 to the 0 power divided by a 3 plus 2 divided by 3 squared plus 2 squared divided by 3 cubed. And the second series goes on.
We have to put right out there.
See, if I had done this, I would have just
Yeah, you just factor.
I would have just like did the formula. But I think you should at least show like the first 2 or 3 terms. Yeah. Because now it's very clear what your A and R values are and that it's geometric. So this is equal to the first term, negative 1/4 over 1 minus the R that we're multiplying by, which in this case is negative 1/2. Because if you go from the first to the second, we're multiplying by a 2 in the denominator and a negative 1 in the numerator. So our R value is negative 1/2. Good.
Exactly. You can get paid for
This is the first term, so that's it.
that. Is it
Wait,
Yeah.
Because there are and Z, R and Z.
So A is your first term, R is the ratio that you're multiplying with to get your next terms. And there's a different way to do this that the answer sheet doesn't show it, but I'll show it to you again. So the second part, our first term is 1/3 divided by 1 minus 2/3. Because 2 to the 0 power is just 1, so our first term is 1/3. And going to the next term, we multiply by 2/3 and stuff. And I'll just write here. So we have 1/3 or negative 1/4 divided by 3/2 plus 1/3 divided by 1/3. That's equal to negative 1/6. Negative 1/6 plus 1, which is equal to 5/6.
So is your A the same for both of them, or do you treat it separately?
No, these are two separate geometric series.
Oh.
So this is the first geometric series, and the second part of the series is the second.
All right.
And you could have done it a bit differently too, and I'll show that. But make sure you have this copy. That's how they show it on the animation. Good? The method that I would have done if I was given the problem, which I'll show you guys, is to just simplify them to find a better way to look at it as a geometric series. So the summation of k equal to 1 to infinity. If we look at it, we have 1/2 times negative 1 over 2, and that quantity is to the k power. And that's equal to, or we still need to add the second part, plus we have 1/2. Yeah. Do you guys all see that? This would be 2k times 2 to the negative 1 over 3k, and then you simplify that. This is negative 1 to the k divided by 2k times 2 to the first power.
so we need to formula is for A 1/2.
No, you need to, A is always the first term. So you need to plug in 1 here. So your A would be 1/2 times negative 1 over 2 to the first power. Okay? Your A is your first term. So this is equal to negative 1/4. For here, if we plug in a 1, we get 2/3. So this is equal to your A. And then your R value will always be what's in the exponent parentheses.
Why is it?
Yeah.
Why is the 1/2 up from 2/3?
This?
Yeah.
That's just because to get them to the same exponent, I did that.
Because of the
One
yeah, k minus 1 there, so you have to do 2k minus 1, so that negative 1 is just gonna be 1/2.
Where are you? Oh, you guys are looking at here?
Yeah,
Yeah.
looking
It's
at how you.
1/2 is like your A for the second part.
Is
Isn't it 1/2 times 2/3?
yeah,
Is it 2/3?
should be 1/3, right? There you go.
That's the thought.
Oh,
Yeah. Sorry about that. So that should be 1/3, because if you plug in a k, you have 1/2 times 2/3.
And then your R is still negative 1/2, your R is 2/3.
Yeah. And then you still do the formula, a over 1 minus r. So they show it the other way because then you did, like, you definitely know which is your first term, and then you look at it and find your r, so you don't have to do the simplification here. But I always did it this way. So if you do it this way, it shouldn't take any points out. Can I erase it? So moving on to partial fractions. So the first one is the integral of 2x squared plus 1 dx divided by x minus 1 squared times x. What's the first thing that you should always check? So so here in the denominator we'll have something of x cubed power, and in the numerator we have x squared, so we don't need to divide. Okay? That's the first thing you should always check. And then we can show that this is equal to, therefore, 2x squared plus 1 divided by x times x minus 1 times b squared is equal to a over x plus b over x minus 1 plus c over x minus 1 quantity squared. So there are several ways to do this. They multiplied everything out, which I don't want to do. Yeah. We can't use we'll need to use the hybrid method, not just the Heaviside method. And do you guys understand why? Yeah, because if you multiply by an x minus 1, we'll still have x minus 1 in the denominator, which will make c over 0, which is undefined. So we can find a first by multiplying everything by x. So limit as x approaches 0, we'll have 2x squared plus 1 divided by x minus 1 quantity squared equal to an a. You guys all see that? Because if we have b times x, c times x, the whole thing goes to 0. The whole thing equals 0 if we approach the limit as x approaches 0. Good? So then that's equal to, so a is equal to 1 over negative 1 squared, which is equal to 1. Are you guys all good with that? Yeah.
We don't have to keep writing out that we're multiplying by a certain factor, do we? Like, do I actually put principles around it, rewrite everything, and make sure I'm multiplying by it?
Like, I put x there, and then you are wondering if you want to rewrite it.
Just get down to the limit step. Or that'd be wrong. I mean, it's technically right. It's not wrong.
In DE, when we did it, we could just go to the limit.
Okay.
I don't know about that.
Like DE, he said.
So if you just went to this step,
Yeah.
maybe write something on the side by like multiply by x or something. Okay, just do that just to cover all bases. You know.
It's not gonna get us off on right.
So we have a is equal to 1. So I'm gonna erase this now. So what's the next term that we should multiply by?
See.
X minus 1 quantity squared. Okay. So then we have the limit as x approaches what? 1. of 2x squared plus 1 divided by x equal to c. Do you guys all understand that? Because the rest of the a and b go to 0. So then if we were to plug in 1 on the top, we'll have 2 plus 1 divided by 1. So that's equal to 3. Yeah. They show a lot of steps here doing the first method, but this is the fastest way. Any questions on that? Can I erase it? Yeah? Is anyone still copying it down? So what do we do now? Yep. So now that we know that C and A values, we only have one variable to find. So we can just make up an x value. What x value do you guys want to make up?
34.
Oh. Yeah, we can go to 2. We should definitely not go to a 0. Okay? Normally I always go to a 0 because that's the easiest way. But we can't do a 1 either. So what's the thing that's synonymous to 1? Negative 1. Okay. We'll just go to negative 1. Okay? So we have 2 times negative 1 squared plus 1 divided by negative 1 times negative 2 squared equal to a negative 1 plus b divided by a negative 2 plus 3 divided by a negative 1, negative 2 squared. Okay? So on the top we have what? This would be a plus 1. So on the top we have a 3. In the denominator, what do we have? Negative 4. And in the denominator here, we have a positive 4. Okay. So just by putting everything to a, let's just go to a positive 4. This will be a negative 4 over 4. This will be 2b divided by negative 2b divided by a 4. So I'm just trying to simplify this. So we have a negative 3 equal to a negative 4 minus 2b plus 3. Therefore, negative 2b is equal to, by bringing everything to the other side, that does not cross out. We have a minus 6 plus a 4, a minus 2. So therefore, b is equal to a 1. Are you guys good with that? And then we can plug in the value for a 1 there. And can I erase this? No? Okay. I'll do it on this. So then if we rewrite the integral, we have 1 over x plus 1 over x minus 1 plus 3 over x minus 1 quantity squared dx. Something you do need to remember is that you need to show the parentheses throughout all of them. Okay? So everything is in the parentheses, and then you have a dx. Because later on, they'll take points off if you don't show the parentheses. Okay? I don't know if they do that already, but they definitely do that in Calc 3. So then if you just do the integrals, we have the natural log of the absolute value of x plus the natural log of the absolute value of x minus 1 minus, and if you do the integral, your u is equal to x minus 1, du is equal to 1 dx. So you just have minus 3 over x minus 1 as your integral plus c. Any questions on that? Does this unit seem easier now?
No,
Yes.
I still despise it.
There was one test we didn't really talk about, like the nth term test, but look over that. And there was a really good problem in the homework they covered today. You guys remember that ball that bounced up and down?
Yeah.
Go over that because that was on my exam.
Oh my god.
Yeah.
Why didn't you do that here?
Do you want me to cover that after this?
Sure.
Yeah.
You do that in the other test. That's what we'll do.
Because that's like a geometric series. You're dividing by a ratio, making it smaller. I'll go over that. But are you guys good with this problem? Okay. All right, quiet down, guys. We have the integral of x cubed plus 2x minus 1 divided by x times x squared plus 1. So what's the first thing we should do? We have to divide because we see that the denominator is also x cubed. Okay? They could have just tricked you and you didn't know. So we have x cubed plus 0x squared. Zero x squared plus 2x minus 1 divided by x cubed plus x. You guys good with that? We need the 0 in there, but not really good. So we multiply it by 1, we get x cubed plus an x. We subtract that quantity, we have x minus 1. So this is equal to the integral of 1 plus x minus 1 divided by x times x squared plus 1. So if we were to break that small part of it, x minus 1 divided by x times x squared plus 1, what would our two factors be? A over x bx plus c over x squared plus 1. You don't ignore it, but you come back to it, okay? Right now, we're just trying to simplify this, and then we'll go back to the integral. So the best way to do this quickest is using the first method, which is equal to a times x squared plus 1 plus x times bx plus c divided by the denominator. If we multiply this out, we have ax squared plus a plus bx squared plus c times x. That's equal to a plus b times x squared plus c times x plus an a. Good. So then if we do the common coefficients, we have x squared with a plus b equal to a 0. X is c, which is just equal to a 1 in this case. X to the 0 power, we have a, which would be equal to a negative 1. Therefore, b is equal to a 1. Any questions on that? That turned out to be easy to simplify. And then if we rewrite the integral, we have 1 minus 1 over x plus bx plus c, which would be 1 x plus 1 divided by x squared plus 1 dx. So what's the best way to take the integral of this? We have to divide it into 2 parts, okay? So we have x over x squared plus 1 and plus 1 over x squared plus 1. If we do our u du on this, we need to multiply the top by a 2 and the outside by 1/2. Okay? And then if you guys can read this, we'll have the integral equal to x minus the natural log of the absolute value of x plus 1/2 times the natural log of the actual value of x squared plus 1 plus, what's the integral of 1 over x squared plus 1? Inverse tan of x plus c. Yeah. Like these values? So I equated the common coefficients. We simplified that, a plus b times x squared. So all the values of x squared, which is equal to a plus b, have to be equal to a 0, since we don't have x squared in the numerator. For just x, we just have an x, and that's equal to a c, because that's the only one to be multiplied by an x. So c is equal to a 1. And then we have a minus 1 without any x component. And on the right side, we see that that should be equal to an a. So, and then you find b is equal to a 1 by simplifying. Any other questions on this? So those shouldn't be, well, as long as you know that you needed to divide, it wasn't that tough after all. And you can do it by not dividing, but you'll just get a wrong answer. So you just have to be careful that you know that you need to divide. Because the math will work out, but it will be wrong. So any other questions on this? And then we can do the problem with the bouncing ball. No? So it says a ball is dropped from a height of 4 meters. So the first thing that you should do is try to draw it out. So the initial height is 4. And each time it strikes the pavement after falling from a height of 8, it rebounds to 3/4 its height. So we can draw that out. So h times 0.75. Okay. So if we look at the height right here, that second value, we are starting with a 4, but then we only go to 0.75 of that. So we know that this height will be equal to a 3. Are you guys good with that? We know that the second height will be equal to a 3, and the next height will be lower and lower. So the distance that we travel, looking at this height, will always be like times 2. Because if we just look at once, it'll just be 0.75 of the height. So each height is correlated to 2 bounces. Okay. So the summation, we start off with 4 plus 2 times the summation of k equal to a 1, going to infinity of 4 times 3/4. Okay, because to find the next height, we need to multiply by 3/4 from 4. Any questions on that? So then after that, it's just a geometric series. So if we do it using the formula directly, we have 4 plus 2 times the first term, which was a 3, minus 1 minus the ratio, 1 minus 3/4. That's equal to 4 plus 2 times 3 divided by 1/4, which is equal to 4 plus 2 times 12, which is equal to 28 meters. So you have your starting height, but then every time it goes to the first height, we have 4 times 3/4 for that, and that correlates to 2 heights.
Why is it raised to the K? I understand why you need to multiply by 4, why you need to multiply by 3/4.
Because each time we need to multiply by a factor of 3/4 to have it decreasing. So as the series goes, it's times 3/4 times 3/4 times 3/4. So the second time it would be 4 times 3/4 times 3/4, because the first time we would get a 3, and then we need to multiply by a 3/4 again. So any questions on this overall? Okay, that's it, guys. Thanks for coming. Make sure you signed in.
I got 22.